Hello everybody, welcome to week 6 part 3 stacks. So this part we continue with the dynamic data structures and we discuss stacks. What is a stack? A stack is a LIFO or last in first out data structure. For examples, you have plates in a cafeteria and return addresses for function calls. Implementation could be static or dynamic. Static is a fixed size implemented as an array. Dynamic, which could be a variable size implemented as linked lists. So the image you see on the slide is a representation of a LIFO structure. Stacks operations and functions. Operations on a stack, you have two operations, push and pop. Push is when you add a value onto the top of the stack. Pop is when you remove a value from the top of the stack. Functions you have is full and is empty. Is full is true if the stack is currently full. For example, it has no more space to hold additional elements. And is empty true if the stack currently contains no element. An example of stack operations when you have a stack that can hold the char values. So notice the push and pop operations and the representations in these images. So we started, for example, with this E, we pushed the K, and then we pushed the G. And also the remove, the pop operations, how we started with the EKG stack and then we remove pop or the G, then pop the K, then pop the E, and we end up with an empty stack. Stack operations, dynamic stacks can grow and shrink as necessary, can't ever be full as long as memory is available, and implemented as linked lists. How to implement a stack? Programmers can program their own routines to implement stack functions. They can also use the implementation of stack available in the STL that we discussed in week 5. Defining a stack of chars named cstack, for example, implemented using a vector. And you can also, as you can see here on the list, you can also implement it using a list. And you can see in the second line. Also, you can implement it using a DQ. Spaces are required between the consecutive operators symbols. Alright, next we have the queue. So the queue is, what is queue? Queue is opposite of stack. It's a FIFO, first in first out data structure. For example, you have people in line at a theater box office, or the print job sent to the printer. Implementation could be static, fixed size implemented as an array, just as the stack, or it could be dynamic of variable size implemented as linked list. Queues operation, you have enqueue and dequeue. Enqueue to add an element to the rear of the queue. An example first you see is an empty queue, and when we try to enqueue E and enqueue K and G, so you can see to enqueue K, use the enqueue, then K within the parentheses, and enqueue G also to enqueue the G to the rear of the stack. To remove elements from the queue, use the dequeue functions. And so the way it works, you remove element from the front of a queue. So in this case, we want to remove the E, then the K. So you do dequeue, then dequeue, you run dequeue again. So the way it works, when you do dequeue function without having to specify if it's E or K, it will always remove the last element, the first element in the front. So when removing an element from a queue, remaining elements must shift to front. So the solutions, so that's an issue with the DQ, and the solution for that, let front index move as elements are removed, work as long as rear index is not at the end of the array. So and then we use this solution and let the rear index wrap around the front of an array and treating the array as a circular instead of a linear, more complex enqueue-dequeue code. Other queue topics, we have the dynamic queues. Like a stack, a queue can be implemented using a linked list. Allows dynamic sizing, avoids issues of shifting elements or wrapping indices. To implement a queue, programmers can program their own routines, just like stack, to implement queue operations. They can also use the implementation of a queue and dequeue available in STL as well. In the STL, dequeue and queue containers, so in the dequeue we have a double-ended queue, has member functions to enqueue, push back, and dequeue, which mean pop front. Queue container ADT that can be used to provide queue as a vector, list, or dequeue, and it has member functions to enqueue, to push, and dequeue, to pop. So how do we define queue? The syntax to define queue is listed here on this slide. So you can define a queue of character named CQ and implemented using a DQ as well. So implementing using a queue, you can do queue char CQ. Implemented using a list, you can do queue char list char CQ, and spaces are required between the consecutive operators and symbols.